Okay, for our first example, we just want to practice finding those expected counts. So we're going to do this both by hand and with StatCrunch. So this data you can find under Donahoe same-sex marriage if you want to open that up in StatCrunch and get ready. The question here was, do men and women feel differently about the issue of same-sex marriage? So what's important to note here is that we have categories, right? Male versus female is a category, and all of these different levels of agreement over here are categories. So even though there are numbers in the table, this is still a categorical variable. Okay, so they took a survey in 2012 of 1,287 Americans, and they recorded their gender and the level of agreement with the statement homosexuals should have the right to marry. Okay, so what's important here is we are going to assume that the variables opinion and gender are not associated, so that your gender has no bearing at all on your opinion toward this matter. And we're going to find how many males were expected in this column of strongly agreeing and how many females were expected. So we have our observed values, but we want to figure out how many were expected. So if we want to do the male expected to strongly agree, we want to take the row total. So the total for the row that we're in is, so EC for expected count, that row total is 323. The column that we're in has a total of 571. And the overall grand total is the 1287 people who were asked. If I multiply that out and then divide and round it off to the nearest whole number, I get 143 expected. So I'll leave this arrow here. What StatCrunch does is they put the expected count in parentheses next to or underneath the observed count. So that is how we would see that. We would see that there would be 143 expected males to say this, and we observed 120. Okay, let's find the women expected for that same category of strongly agree. We would take the row total would be the same. The row total is still 323, but the column total is different. The column total is now 716 divided by 1287. So the expected count for women is 180. So it looks like we observed more females than we expected and less males than we expected. Now, if we wanted to actually run a full chi-square test, we would have to find these expected counts for all of these remaining cells. So that's going to take time if we're doing it by hand. And then we would have to perform this calculation here for every single one of those, add them all up. Again, not hard calculations, but very time-consuming calculations. So we're going to save a lot of time by relying on StatCrunch to do this stuff for us. So let me go ahead and show you, even though finding these expected counts is totally doable by hand, let's see how quick it is to do it in StatCrunch. So if you load up that data in StatCrunch, you can simply go to Stat Tables, Contingency. This is why it's important to know that these two-way tables are called Contingency Tables. We do have a summary because we don't have each individual person's answer. We have that data summarized to us. The columns that we're dealing with are male and female. And the other one is just the label. The option is the label. And what is easier for you to see if you're on a PC or a laptop probably than a tablet like me is that under display, I believe this is already dropped down for you. And expected count is an option there. So I want to display the expected counts. And there are other things we can do in this area, but for right now, this is all we care about. We just want to be able to